From Trimble Construction, you're listening to the Connected Construction Show, where we connect you to the contractors, owners, designers, engineers, and construction professionals who are finding better ways to work. And now, here's your host, Matt Sprague.
Hello and welcome back to the Connected Construction Show. I am your host, Matt Sprague. Very excited to have our guest here today. Before we get to our guest, also excited to have back again our co-host, Sumele Aruofor, who is the Senior Strategic Marketing Lead at Trimble. Sumele, hello. Welcome back.
Nice to be back. Thanks for having me again.
It's our pleasure. And getting right into it. So we have Adam Omansky, who is the founder and CEO of ClimaTwin, with us today. Adam, thank you so much for joining us.
Thank you for having me.
It's, I think it was 4 years ago that you and I met in a small coffee shop in Manchester, New Hampshire, when you were working on another company, which was WeatherBuild. And since then, we've had conversations, and then you've now moved into ClimaTwin. But before we get into ClimaTwin and everything like that, tell the audience a little bit about yourself, your background, what you do at ClimaTwin, but even kind of what build up to that.
Yep, great. So I started my career as an architect, building architect, not a software architect. Practiced here in Boston. I'm based in Boston. And then I moved overseas to Budapest, Hungary, to the owner side in an owner's project management role. We developed a luxury hotel over in Budapest. After Budapest, I came back to Boston for school. And then based on some of the challenges and pains I experienced overseas in an owner's project management role, I started a company called Bella Systems, which was early field management software for the construction industry. So think iPads on construction sites. At Bella, we had programs for quality, safety, commissioning, materials management, handover, and field BIM, so building information modeling in the field. That company was acquired by Autodesk, and it's now Autodesk BIM 360, BIM 360 Field, which you're probably familiar with. After that, I went out and began interviewing many of my former customers, all top contractors and owners, and I was hearing over and over again this problem of weather in the construction industry. In many cases, project teams and field crews would look at generic weather forecasts, in some cases use guesswork or maybe best judgment as to proceed ahead with the work or not, or maybe move the crane pick to later in the day or later in the week. So there was clear that there was a problem of weather in the construction industry. At the same time, I partnered with a multidisciplinary research and development company based here in Boston and on the West Coast. And at the time, they were developing a solution in agriculture, ag tech. And they had also started a company called Dark Sky, which was recently acquired by Apple. It's now Apple's default weather. So we started WeatherBuild, which is weather decision support for the construction industry and built environment. We had both scheduled reports and real-time alerts that were deeply integrated to the project schedule. That company was acquired by an industrial holdings company in October of last year that's primarily focused on aggregate supply chain management. And during my time at WeatherBuild, we were hearing about the need for a longer-term, more strategic solution looking out years and decades, if you can imagine, as opposed to minutes, hours, and days. So for us, this was a different company, different inputs, different product, different customers. So that was part of the impetus to start ClimaTwin.
So essentially, it was kind of like really kind of digging into that a little bit more in terms of the impetus. So in terms of the weather build to ClimaTwin. So weather build, if I understood you correctly, was very short term weather information to make adjustments, if you will, whether it's for schedule, but also for safety purposes. Where ClimaTwin was like, hey, can we move this to a little bit more future looking? So as we start to schedule the projects that we're going to do, where's the sweet spot in order to best schedule this project so that weather doesn't affect it as poorly, if you will. Is that kind of the gist?
Yeah, that's right. So we're looking out years and decades. Our models go out to 2070, so about 50 years, if you can imagine, based on two greenhouse gas emission scenarios, high and very high. Regrettably, we've already passed the point of no return for low emission scenarios, and sort of moderate or medium scenarios are the status quo nowadays. And with ClimaTwin, we're focused on primarily 3 user groups. So engineers, owner operators, and governments, whereas with Weather Build, we were primarily focused on contractors, general contractors, construction managers, EPCs.
I want to maybe just dig in a little bit more, Adam,
sure.
In terms of like the how does this relate to to the climate crisis that we're experiencing / expecting to continue, and how that might relate to any infrastructure vulnerabilities?
Yep, it's a big question. So
you can break it up into smaller ones if you want.
Yeah, so we're helping infrastructure stakeholders mitigate climate risks, assess adaptation actions, prioritize resiliency spend. So if you're a consulting engineer or a large owner with geographically distributed assets, how do you prioritize your hardening spend over the next 10, 20, 50 years? I think we have about an 8 to 10 year time window of opportunity now to take action in terms of addressing the climate crisis. Regrettably, as we know, America's infrastructure is generally poor nowadays. I think
C-, right?
That's right. Yeah, the ASE report card ranked our infrastructure at C-. So it's already failing. To compound matters, many standards and practices assume a future climate the same as today's, which is not sustainable moving forward. We look at the benefits through a number of lenses. The first is saving lives. So health, safety, and welfare of our communities. The second is the resilience economics, the monetary return. It's somewhere in the order of magnitude of 5 to 10x. So savings in the billions or hundreds of billions if you look at infrastructure worldwide. And we also know that it's more cost effective if you look at a benefit cost analysis over the lifetime of assets to take action now or in the near future, as opposed to waiting after the fact, 10, 20 years in the future. We look at both acute and chronic climate hazards. You can think of acute climate hazards as extreme weather as a result of climate change. So things like storm surges, flash floods, extreme rainfall, or severe drought, on the other hand. So those are all impacting us nowadays. Just turn on the news. You can see wildfires on the West Coast and floods in the Gulf Coast, just drought in the East Coast, heat waves, wildfires. In fact, we're currently working on wildfires, wildfire models as they relate to the energy infrastructure, in specific electric utilities. We currently have models for temperature, precipitation, wind, and sea level rise, both coastal and riverine sea level rise. Wildfires are complex in that they're compounded or exacerbated by other factors. So think high temperature, low humidity, high wind, low precipitation, plus a range of other environmental factors. In the case of electric utilities, when it's hot in the summer, people are using more electricity, running air conditioning. It puts additional demand on electric utilities, power line systems, overhead utility systems, and in turn that can overload systems and trigger wildfires. So
when you're trying to do the climate risk analysis,
yep.
So what are your current challenges in trying to put that together?
Yeah, so there are a number of challenges. Raw climate models are readily available nowadays from both public and private sources. So we aggregate raw climate models from a number of sources. One of the challenges is that those models are first locked in scientific formats. So you need to be a climate data scientist in order to understand the models. Second, the global climate models are at a very high resolution, somewhere between 100 to 300 kilometers, which is great if you're a state or a country. It's not great if you're an engineer or an owner or operator of infrastructure assets. So we use some proprietary techniques to downscale those models from about 100 to 300 kilometers down to about a kilometer, which is the local scale of infrastructure assets. So that's the first challenge. The second challenge is then connecting those models to the assets. We use some digital twin technology. So it could be as complex as a city or an electric utility that has 1 million utility poles distributed across a region, or it could be a model of an individual asset like a bridge or a dam or a plant, for example. So that's the second challenge is connecting the climate models to the digital twins. Now, you think digital twin, many folks think about a three-dimensional model or a building information model. In many cases, it is a model. In other cases, it may be something as simple as, in the case of a utility pole, an ID that corresponds to a metal tag on a pole, together with a lat long, a geographic location of the pole, and some other data and metadata. And then the third challenge is the risk analytics after we connect the climate models and the digital twins. So you have a million utility poles geographically distributed. The poles are at different elevations, different ages. They may be inspected at different times. How do you prioritize your resiliency spend? What poles do you harden or shore up? What poles do you replace, and over what time period? So that's the other challenge. Clearly, with many geographically distributed assets, this is only a problem that a machine can solve with a computer, whereas it may be somewhat less challenging if you have an individual asset like a bridge or a dam, for example.
That's interesting because you're prior to that last challenge that you just explained. my brain, the way it was thinking about ClimaTwin was purely on the planning and design phase of a project, but very much on the asset management and so the operations and maintenance of existing assets as well. So that was an interesting piece to kind of open my mind to it.
Yep.
So in an effort to continue to open my mind to how this works a little bit, at least for me, it's all around like use cases and stories and whatnot. So do you have like some customer stories that you could share with us in terms of how they've implemented ClimaTwin and some of the benefits that they've gained from it?
Well, right now, based on market feedback, we're focusing in on energy infrastructure, as I noted, in specific overhead utility systems and power line systems. So we're in the process of a complex analysis for over 1.5 million utility poles and overhead lines. Not ready to report the successes as of now, but we're excited about the progress.
What are the expected? So instead of not being able to report it, so what's the expectation in terms of the benefits?
Yeah, it's first helping the owner and operator and the consulting engineers prioritize the hardening spend, prioritize the adaptation actions across a large network of utility services.
And when you say hardening, does that mean shoring up, replacing? Yeah, right. Okay.
That's right. Outright replacement, shoring up poles and lines, for example, evaluating alternative options like putting lines underground, which in some cases may not always be an option, relocating lines.
And I guess overall, the benefit for the owner operator is that they have less losses. Like in the event of an extreme weather event, their infrastructure is more resilient, so there's less loss of that power supply to the places that need it. There's less loss of capital and infrastructure, and it just all supports itself and helps the entire thing keep running, right? Like, so long term, that's the benefit.
Yes, we all depend on electricity nowadays. I think there are few facilities that are self-sufficient. Some may work on solar, others may have 24-hour diesel generator backup. But we depend on electricity.
Yeah, great. And I guess as a follow-up to what Matt just asked, your solution is potentially unique to the market and the problems that this specific market faces. Is there anything that differentiates ClimaTwin from other products on the market?
A number of things, and just going back to some of the challenges I discussed. First, we use some proprietary techniques to downscale the climate models. We use some of our own solutions to connect the climate models to the infrastructure assets. And on top of that is the risk analysis. I should note that we do leverage an Earth Sciences supercomputer, which is purpose-built for Earth systems models and this type of climate change analysis. Of course, you could do it on other platforms like Amazon Web Services or Microsoft Azure, but it's significantly more efficient to use this Earth Sciences supercomputer.
Interesting.
Yep.
Matt, did you have one more question? I have a couple more. Shall I go?
Let them roll.
Okay. I guess so. So right now the focus is on energy supply and those types of infrastructures, and predominantly in North America, I would imagine. What's next for ClimaTwin?
Well, I noted we're working on the compounding and cascading events that exacerbate like wildfire. We're also developing our tools to be flexible and extensible so that they can extend to other adjacent sectors. So clearly there's a demand in energy. We recognize there's also a demand in transportation, roads, bridges, in cities, in buildings, could be a high rise or skyscraper or an airport or any other kind of vertical construction. Focused on energy for the time being, focused on compounding and cascading events next, with the understanding that we could expand to adjacent sectors. We have heard the need, for example, in transportation, but it's not a focus as of now. Clearly with IIJA, there's tremendous amount of money from the federal government now to support climate change and infrastructure resiliency.
And just to clarify, for those who aren't in the US, it's the Infrastructure Investment and Jobs Act in the US.
Yeah.
Can you imagine? Yes. Okay. Great. I'll be the eyes for the rest of the global audience. I got you guys. I guess looking ahead 2030, what kind of impact would you imagine that ClimaTwin has made? How do you envision the kind of impact that ClimaTwin might have had?
Yeah, nowadays a structural engineer, for example, will do structural analysis of a bridge or a building as a standard practice, as part of the sort of professional code of ethics. I see the same with climate risk analysis, that every asset, both new construction or existing assets, will get the same degree of climate risk analysis. So I expect it to be standard moving forward. Regrettably, it's not a standard now, and really varies sort of state by state or owner by owner or asset by asset. But I expect it to be a standard in the near future. In the same way that you do a structural analysis, or in many cases, an environmental analysis.
How exciting would it be if that was the case across the entire world? Because, climate change is affecting every single nation and every single region. So it would be so cool if it was like embedded into the curriculum for built environment professionals, and it just kind of seeps into the way that we do work.
Yeah, I'm confident. Yeah. I'm confident we'll get there. That's where the industry and practice is headed now.
Yeah, it almost seems like the natural progression here is for it to plug into artificial intelligence. So it's going from predictive to to prescriptive.
Yep.
Mm-hmm.
I mixed up those words for a second there, but you're having to actively as a structural engineer go in and be able to pull up the models from ClimaTwin to be able to get the information, as opposed to when they having it being plugged directly into the tools that they're utilizing to create these pieces. And whatever they might do, like they try to put a certain element in, and it'll be like, that's not a good idea.
Yeah.
Like, you should probably think about XYZ unless you move this into a completely different geography or something along those lines. But it's exciting to hear these type of early stage data evolution type of tools.
Yep, that's exactly where we see it headed. To your point, Matt, comparing baselines, where we are today with actual outcomes or ground truth based on extreme weather compared to longer term probabilistic forecasts. We also see the connection with IoT, so weather stations, sensor suites, data loggers, rain gauges to feed those actual outcomes or ground truth back into the model.
Well, we are at our last question. As every guest is subjected to the last question, you are going to be no different, Adam. So it is, what is your motto, or what is a motto that you find intriguing that is interesting in terms of business or personal to kind of direct how you live?
Sure. So I've two wonderful children now, a 4-year-old and a 2-year-old, and being a husband and a father, it's really invested me in generational thinking and environmental stewardship. So how are my actions and decisions benefiting future generations? And it's really forced me to ask, what world will my children grow up in? How will the world be for my children in 50 years, in 2070? So that's what's driving me, personally, professionally, with ClimaTwin. It's really about benefiting future generations, and I think the onus now is on the architecture, engineering, construction industry to drive that change.
Awesome. Well, thank you. And before we let you go, just in case anybody in our audience wants to learn more about ClimaTwin, wants to connect with you, how do they find you? How do they learn more?
Yeah, sure. So go to climatwin.com, or you can email us at info@climatwin.com.
Awesome. Well, again, thank you so much, Adam, for joining us today and sharing your story about ClimaTwin. Sumele, thank you very much for joining us and being able to add some really insightful questions to the conversation. And as always, thank you to everybody for listening or watching, depending on where you're seeing this or hearing this. And until next time, everybody, stay connected.
Thank you for joining us for this episode of the Connected Construction Show. For more information, visit us at connectedconstructionshow.com.